Hello everybody and welcome to How to Make a Horror Game from Scratch 2024 updated, way better version. For those of you that watched the first one, this is going to be a lot different. It'll be a lot more streamlined, a lot cleaner, and it'll be easier to drop in and out to episodes that you need, and you can avoid the ones you don't. I'm also going to be not making a specific game because it doesn't really make sense for you guys to make the game that I'm making. And I'm just going to tackle a lot of horror genre mechanics. Then, if a certain video needs context from another video, I'll make sure it's linked in the description. And if you're a Patreon patron, I will update the project file once a month and let you just download the project I'm working on right in front of you, so that way you can skip all the coding and get to making your game. A link to the Patreon will be down below. For this How to Make a Horror Game from Scratch, we're going to be using Unreal Engine 5.3.2. Older and newer versions should work. However, I'm just letting you know that it's 5.3.2 in case yours is a little different. I'm more of a fan of first person, so I'm going to be starting with the first person template. However, if there's enough push for third person, I'll add that as well. However, for now, go ahead and create a first person template. I'm going to just go ahead and name mine Scratch 2024, Horror Game from Scratch 2024, and I'm gonna hit create. So as I'm sure the title of the video says, this one is going to be all about implementing our interaction system, specifically sending a message to another blueprint that says, hey, I've interacted with you, do your thing. In order to do this, we're going to need something called a blueprint interface. It's a way for blueprints to communicate with each other, and it's kind of like a binding contract that anything that implements that interface, it's basically saying, I promise I'm going to have a definition for whatever is coming in. If that sounded confusing, don't worry. I'll explain it as it's necessary. Let's go ahead and open our content drawer with Control Space. I'm going to go over to the furthest backed content folder here, and I'm going to create a new folder, and I'm going to make this underscore just so it shows up as the first folder. I'm going to call it underscore dark BPs like that, and I'm going to open that up. Within dark BPs, as I said, we're going to be creating a blueprint interface. So we're going to create a new folder, and I'm just going to call this interfaces. Not like a user interface or a HUD that you would see on the screen. Within interfaces, I'm going to right click, and I'm going to go up here to blueprints. And within here, we're going to create a blueprint interface. A reminder, this is a contract or a way for blueprints to send messages to each other. Just want to remind you. For blueprint interfaces, I like to do BPI, all uppercase, and then I'll do an underscore. And in this case, we want this to be for interactions. So BPI underscore interaction. And I'll hit Control-Shift-S. Now, you'll note that I hit Control-Shift-S a lot. Control-Shift-S saves all. So like, let's say I did something and like 3 different things were affected by what I just did. Control-Shift-S makes sure it saves all of those. Now I'm going to go ahead and open up the BPI interaction. You'll see something that looks like a pretty standard blueprint. However, our details are over here on the bottom right, and we're given this new function here. This new function is a reflection of, on the right-hand side here, you'll see we have a list of functions, just this thing here that says new function. So what I'm going to do is I'm going to click new function. I'm going to press F2, which allows me to rename it. And I'm going to name this BPI underscore interaction request. Now, some of you might be wondering why I'm including the BPI. The BPI is so whenever we're looking through a list of things in the context menu, like when we right click, oh, I guess I can't create a node here. But when we right click and we get this huge context menu, we'll know that because it says BPI underscore, we'll know it's not only something we created, but we can quickly identify that it's talking about an interface. And then what I like to do, especially with something like an interact request, I like to go over here and on the output, I like to do a plus with a Boolean and it just says success. I know some of you still might not know what's going on and that's okay. But just understand that essentially we're going to send the request, and then because we have a return node or an output, we'll be able to then define whether or not the interact request succeeded and have different results depending on if it succeeded. Again, complicated in theory if you're new, but don't worry, just keep following along and I'll explain as I go. So great, we've created the interface. Now we need to set up a button that the player can use in order to send out that interact request. I'm gonna hit Control Space. I'm gonna go to Content, and I'm actually just gonna go ahead and use the first person template blueprint because it's here, it's nice, it's ready to go. I'm gonna open this up. Just so that way it's up here in the tab because I don't need it quite yet. I'm gonna hit Control Space again. I'm gonna go back to first person here and I'm gonna go to input instead. You'll see we have an IMC default and an IMC weapons. This means input mapping context. So essentially it's saying the mapping of my keys is going to be slightly different depending on the context. So for example, default means we haven't picked up the rifle, whereas the context for weapons is we have a weapon in our hand. Let's look at an example. So right now we're in the input mapping context of default. I don't have a weapon, these are my controls. But when I pick up the gun, we have some code that says change the mapping context to weapons. So now when I left click, it knows to fire the weapon. It's not trying to fire the weapon whenever we don't have one, and it's just a nice little way for you to be able to change your key bindings on the fly. Like let's say you wanted to enter a vehicle. Your context is probably going to change compared to when you're running around. However, our game isn't going to have a gun, so I'm not going to delete weapons yet. I'm just gonna go ahead and open the context for default. And if I open up the mappings here, you'll see that we have IA jump, which stands for input action. So there can be an input action for jumping, moving, and looking. Obviously, we want to add one for interaction. But if I were to add a mapping, you'll see that obviously there's not one here for interaction. Now, I've never done it this way, but I see that it's here and it's convenient. But at the top, it says we can create a new asset. So let's do that. Let's do create new. I'm going to, since I'm creating it for something that I've made and it's not the default, I am going to put it in my Dirk BPs. And I'm just going to right click and hit new folder and just type in input, kind of like how they did. And just call this actions. Then within actions, we'll go ahead and create the IA for input action underscore interact. And we will go ahead and hit save. As you can see, and we now have the IA interact listed in our mappings. If we further expand the interact, you'll see that we have this little select the key value keyboard here, and it's set to none. I'm going to set my interact to F. So what I can do is just click this keyboard and press F. Something you can do if you want multiple key bindings on one thing is you can actually go here and hit this plus, and you'll see that it's given me an additional value that I can use as a key binding. This is useful because if you look, we can actually go in and go to gamepad and set up different gamepad keys as well. By default, I'm not going to do this, so I'm just going to go ahead, leave interact set to F, and press save. I will say one inconvenient thing about creating the interact this way was we actually need to change something within that file that was created. So I'm going to click this little folder here with the magnifying glass, and it'll bring me straight to it in our content drawer, as you can see, and I'm going to open that up. In here is a lot of stuff to be scared of, but don't worry. All we need to do is see how it says value type digital bool. We know that's correct because a button is a digital bool. It's saying, is it pressed or not? So therefore, true or false. And that's where digital bool comes from. However, what we want to do is things that trigger it, we want to go ahead and hit add. And we want this to be whenever they press it, add, or whenever they release it. So now, whenever they press or release whatever button we set, this will trigger. Let's go ahead and hit save and kind of look at what we just did. If you remember, I opened up my character value or my character here, and these are the enhanced input actions that are by default. We have the jump, the move, and then of course our camera input for the mouse. I wanted to add an additional one so they could interact. So in the context, we added a new input action called interact, and we set it to F. Then within the file created that is the input interaction, we just simply said that yes, it is a digital bool, which was the default, and we said press and release. Let's go back to our first person character. With the first person character, I'm going to hit Control-Shift-S to make sure everything we've done is saved. And then I'm going to press the compile button. And you might be wondering why. Anytime we need access to a file outside the one we're working in, and we haven't compiled that file yet, there's a chance it won't see the updates that we've changed outside of it. But by compiling, it does a little bit of a refresh to make sure that it knows that the outside files have changed. So if you look at the jump input, you'll see there's enhanced input action, IA_jump. If we right click on the graph and we start typing in enhanced input, and notice I used a space, you'll see that we're given options that look like they could be useful here. We have the values and we have the events. In this case, we want the event. An event is like this red node here. It means something is going to happen, an event, and I'm going to run some code. In this case, the event will be when they press the interact key. So under action events, go ahead and hit input action interact. And just like the ones above, now we have an event here for the key we just created. If we expand it, you'll notice there's all kinds of things here. We have when it's triggered, when it's started, when it's ongoing, canceled, and completed. Some of these are useful for us right now, and some of them aren't. Triggered means anytime your keyboard or whatever button is fires. And what I mean by fires is, have you ever held the button down on a keyboard? Like for example, if I hold A, all those A's are going off. Well, anytime this triggers, it would be if I'm holding A, it's going to trigger every single time A goes off. Or in this case, F, because we said it's F. Started means I only take the first time it goes off until you let go. So for us, that makes more sense. If they press and hold F, we only want it to interact one time, not thousands until they let go. However, what do we actually need to have happen? Like, great, we have a key now and it can be registered in our character, but what do we do? Well, since this is a first-person game, we're going to use something called a line trace by channel. However, we're not going to do the line trace by channel straight out of our started here. We're actually going to make it a function so it can have multi-purposes going forward. On the left-hand side, you'll see that we have functions here. Let's go ahead and hit plus, and you'll see that we have to name it. So let's call this just line trace. Our line trace, we're going to want to know how far we want that line to shoot forward. Because whenever we do our line trace, it shoots a line forward. But if it went infinitely, well, we would have infinite length interaction, which I don't think makes sense. Not to mention, if we want to do any other checks using this line trace function, by setting the input, let's go ahead and do that, as length, and then setting it to a float because that is what it will be using the length number as. Now we can call this line trace and check any length. So now that we have the function that requires a length, let's go ahead and pull out of the execution pen and type in line trace by channel. Not the multi, just the regular. Also, fun fact, if you grab both these nodes and press Q, it will straighten it up for you. Okay, so how do we draw a line in 3D space and check if it hits anything? Well, we need a start point and an end point, right? If where this finger is located is the start point, and where this finger is the end point, we could easily draw a line between the two and see if it hits anything. For example, if I was to lower it, right now it would hit my microphone. So as you can see, we're given two vectors, which is just a fancy way of saying a position in 3D space, that act as the starting point and the ending point. I'm gonna go ahead and create a little bit of additional space here. With an interaction system, typically what you're going to want to do is use the camera as, typically what you're going to want to do is use your first person camera. So let's go ahead and drag that out. And we're going to get its, world location. So wherever the camera is located, that's where the line is going to start. So if I take this and I plug it into the start, now we have our first point. Our first point is my face, essentially. However, how do we know which way the camera's facing, then go forward in that direction so far? How does that work? Well, luckily we can do something called get forward vector. So if we go ahead and pull out of our camera again, and this time we do get forward vector, it's a fancy way of saying, what way are they facing? Okay, great. So we have a forward vector, and we need to multiply this. So let's go ahead and type in multiply, and let's discuss. Why are we multiplying it? This is going to be the length that we want the line to be. Now, you'll note that the input we created is length, and it is a float. But here, we're multiplying by another vector. If we just right-click this, we can hit pin conversions, and then just do to float single precision. Now, there's two things we can do here. You could either take length and plug it straight in like that. Works perfectly fine. Completely valid way to do it. Or, because it's a function, something we can do is actually just right-click and hit get length. And it knows, because we're requiring the input of length, it knows it's going to have access to this variable. And we can just plug that straight in. Now remember, we're dealing with 2 points in 3D space. The first point is our camera's world location. As of right now, the second point that we're working on doesn't have that information. As you can see, this isn't plugged into this at all. So what do we have so far? We have a direction with the get forward vector, and we have a length. So by default, it's going to assume world point 0, 0, 0. So from the origin, it's saying get the forward vector of our camera. So from 0, 0, 0, we have a direction, and we have a length. So we have a general spot for the second, like the end point, but it's not where we want. It has to be from the first person camera, get the forward vector, go forward. So luckily, it's as simple as adding in the world location of the first person camera. So if we simply take the get world location and type in add, we can then take our forward vector in length and plug it straight in like that, and we have our endpoint. Compile and save. For the purposes of debugging, we're going to go over here and do draw debug type, and we're going to switch this to for duration. This is going to draw a red line in 3D space whenever any time this goes off, and that is for our purposes of testing and making sure things are working. Then on this function, what we're going to do is we're going to need this out hit and this return value. So I'm going to go ahead and click on this line trace purple box here, which just means I've clicked on the function as a whole, and I'm going to create an output. The output, honestly, for now, just go ahead and hit this little X here, so that way it's empty, but we have the return node. So go ahead and take the execution pin, plug it into the return node, and then you can just take the out hit, drag it onto the return node, and return value, put it onto the return node just like that. And we're going to hit compile and save. So now let's go back to the event graph, and here's our button. So this is our F key, our interact key. Let's drag our function we just created onto the event graph. Remember, we're going to use the started execution pin because we do not need this to fire multiple times. And see, now it wants me to specify a length. What I'm going to do is for specifically our interaction range, I'm just going to create a variable over here. And I'm just going to call this reach length. This will be the general length that the player is able to reach forward. I'm going to change it to a float, and then I'm going to plug it in to our length. Some of you might be thinking that seems a bit redundant. Why not just use the reach length in the line trace function? The reason I'm not doing that is because it lets me use a line trace in other places now that might have a different length. So yes, it might seem redundant, but it's basically just not hard coding it for one purpose only. I hope that makes sense. I'm gonna go ahead and hit compile and save so I can access the default value of the new variable we created. I'm gonna click on reach length and you'll see that by default, it's 0. We're gonna set it to 500 by default. It's a little bit of an arbitrary number. I know roughly how far that is in Unreal Engine. That might be a bit too far, but for now, that should work. If you remember, we said debug type, go ahead and draw the red line for the duration. Let's just go make sure our button and new function is working appropriately. I'm gonna go ahead and hit play here. And if I hit F, you'll see that a line from my face 500 units forward is now being drawn. And as you can see, it's not hitting anything. If it hits something, you'll note that it's denoted by a little red box. So great, it's working exactly how it should. Also, side note, I decided I'm actually gonna rename this function. I'm gonna call it FP underscore line trace because it implies first person line trace. It's letting us know, in case we ever come back to this, it's saying, hey, this is going to be from the first person perspective. That's the only reason I'm changing the name. I think it just makes more sense. Now, what is the out hit and the return value here? If you remember, these are simply what's being returned from our line trace by channel. So the return value is going to be, did we hit anything? So what we're gonna do is we're gonna hold B on the keyboard and click on the graph and it will create a branch. Now you can do that by just right clicking and typing in branch, but it's much faster and efficient to just hold B and click and you can make branches for days. We're gonna plug in the execution pin and we're gonna plug in that return value. So what's happening now is we do our trace. Did we hit anything? Because if we didn't, we don't want any code to run. Why would it matter? If we try to interact and it doesn't hit anything, clearly we're not looking at something that's interactable or anything at all potentially. However, if we did hit something, how do we know if it's something that's interactable? Well, if you remember, do you remember how I kind of described how an interface works? It basically sends a message to something, or it's kind of like a contract. It's saying I will have a definition for whatever you're sending to me. Well, if something is implementing the interact interface, then we know that it will have some kind of response to the fact that we're interacting with it. Makes sense? Well, luckily, it's very easy to check if whatever we hit does implement that interface. So what I'm gonna do is I'm gonna go out the out hit here, because the out hit is essentially, if we did hit something, out hit then contains the information of whatever we hit. So out of out hit, I'm gonna pull out and I'm gonna type in the word break, and you'll see that we can break the hit result. This is all the information that our line trace gets whenever it hits something. It's quite a bit. In this case, we should pretty much only be checking for hit actors. So I'm gonna go out of the hit actor and I'm gonna type in does implement, and you'll notice immediately does implement interface. And if I click on that, you'll be able to see all the interfaces that exist. Obviously there's a lot that come with the engine by default, but ours is of course BPI underscore interaction. Then just to make things nice and clean, we can close this down and it will keep the hit actor there out for us. I'm gonna grab both these, press Q, save and compile, do that all the time. Control Shift S right now, just do it. And you're gonna see we need another branch as we've got another Boolean return value. So did we hit something? Yes, fantastic. But does it have the interaction interface? Because if it doesn't, we don't care that we hit something. But if it does contain the interact interface, we need to send it a message that says, hey, we're trying to interact with you. And luckily, that is indeed the power of the interaction interface. As you remember, out of the hit result, we have the hit actor. So out of the hit actor, I'm going to drag all the way over here, and I'm going to type in the word message. Message, as you can see how there's a bunch of stuff here, and at the end there's these parentheses, and inside it says message. That means it's sending, usually, I'm sure there's examples and someone will yell at me, but usually it means that it is an interface. Now we could go through all of these and find ours, but I'm not gonna do that. I just wanted to show you that the message exists, because what we're gonna do now is we're gonna type in the word, if you remember, the function, actually let's just go look so you don't have to remember. In the BPI interaction, the function was BPI interaction request. So remember, grab hit actor, pull it all the way over, BPI interaction, and there it is. BPI interaction request. This is important, in the parentheses, message. Because the reason this is important is if something implements the interface that you are trying to send a message about, it can also access any of the definitions you've created for that interface. So for example, if it wasn't a message, we would probably be trying to run BPI interaction request, whatever we've defined in this specific blueprint. If that makes sense, great. If you're confused, don't worry. It's fine. Just know that whenever you're talking between blueprints, you want it to say message. And as you can see, the node very conveniently contains an envelope for us to let us know that it is indeed a message. So did we hit something? Yes. Does it contain the interaction request or the BPI interaction? Yes. Great. Send it a message letting it know we're trying to interact. However, this looks a little jumbly. So what I'm going to do is I'm going to double click on this blue line. It'll create a pin, and I'm going to move it over to something like that. I'll do it again, create another pin, and we'll put it on about the same level as the one on the left, and that makes it a lot more clean and easy to follow. And we'll hit compile and save. So you can see, if you remember, I added a return node that offered whether or not it was successful or not. The reason this is important is because if we have context for what we're interacting with, in this case we may not, because as you can see, we're sending a generic request forward, but we can now do something depending on if it was successful or not successful. For now, we're not going to do anything about that. We're just going to hit compile and save. I'm then going to grab the entire thing. I'm going to press C to create a comment. And I'm going to just type in interact request like that. I like to use a nice purple color. I would recommend changing the color because you want it to, 1, be visually appealing. 2, you need to know that you created it. And 3, if you use colors, you can start to differentiate things. For example, all my hotkeys and the code that goes with my hotkeys could be blue. Then all my system stuff that has to do with stats could be red. And it makes finding your code in these massive piles of code, because trust me, it'll get massive, way easier. Like I said, I like to go with a nice purple. So we're going to remove all of the green. We're going to set red to like 0.5, and the blue on 1 actually doesn't look too bad. Another thing we can do is on the right hand side, we can show bubble when zoomed. And if we now zoom out, you'll see we can always very quickly find that interact request code that we just created. Compile and save. Now let's quickly go make a blueprint that can accept that BPI interaction request, so you know how to implement the interface and also define whether or not it works or not. I'm going to go ahead and open up my content drawer with control space. I'm going to go back to dark BPs, and I'm going to create a new folder, and I'm going to call this actors. And then actors, I'm going to go ahead and right click and create a blueprint class. It will of course be an actor, and I will do BP underscore interaction test. Control Shift S and open it up. For the visual, I'm just going to go ahead and add a static mesh really quick. So we'll type in static mesh. I'm going to call this SM tester. And on the right hand side, you'll see that we can set the static mesh that we just added. And I'm just gonna go ahead and add like this cone, for example. Good enough for me. And we'll hit compile and save. And of course, now what we need to do is implement that interface. So I'm gonna go over here to the class settings, and on the right hand side, you'll see that we can implement an interface. So if we open up this menu, or I guess we don't technically have to open it, we just need to click add here. And ours was called BPI Interaction, which is that file we created, this one with the function in it. And we can hit compile and save. When I added this BPI interaction, on the left-hand side, you'll see that under interfaces, now we have this little gizmo with an arrow and it says BPI interaction request. Sound familiar? It should, because that's the function we created and the message we sent in our code. So if we go back to the interaction request, we can actually double click on this now, and voila. Does this look familiar? It should, because it's right here. However, now we can define what this specific thing does whenever it receives that interact request. So whenever we interact with this thing, or it gets the message that it's been interacted with, what do we want it to do? Well, we're just testing, so let's have it destroy the actor, as in itself. Go ahead and destroy itself, and then return that it was successful. And we'll hit compile and save. So we'll go back to our little map here. I'll go ahead and open up my content drawer, and I'll pull out one of our little cones that we created. Now there's a small chance this cone doesn't have collision, and this is just not gonna work. But if that happens, I'll show you how to fix it. Let's go ahead and hit play. Now, first off, is there collision? Oh, there is, thank God. So what I'm gonna do is I'm gonna look at it, press F. You'll see that the line hit it, and you'll notice that it's gone. That's because whenever it hit, right, we did a line trace, it said, yes, you hit something, and it did implement the interface. So it sent a message of BPI interaction request. Then we defined what happens whenever it receives that request. And in this case, it says destroy yourself and return that it was indeed a success. It's good to be back making horror games. This is, of course, just the fundamentals, the base of what our horror game is going to be, but a very important one, and one that I hope taught you something. Remember to like, comment, and subscribe, and remember, every month I'm going to update the project on my Patreon so you can download it and have all the code for yourself. Link will be in the description. But for now, I'll see you guys in the next episode.